Let's find out what happens to pressure in a pipe when the height changes. In this example, we have a pipe that has water going through it at a pressure of 1000 kilopascals at a velocity of 3 meters per second at the starting point. The velocity and diameter remain constant through the pipe, but the pipe increases height by 10 meters. We need to find the pressure at the point with increased height, point 2. We will once again use Bernoulli's equation. This is the equation that shows how much energy is in the water inside of the pipe. Being that the energy is conserved, energy point 1 equals energy point 2, we can take the Bernoulli equation at the starting point and set it equal to the Bernoulli equation at the second point. The velocity remains the same, so the kinetic energy can be eliminated from this equation. We can then rearrange the equation, and we realize that we really are just taking the original pressure plus the density times gravity times the height difference of the 2 points. Once we plug in our numbers, being careful to remain in the proper units, pressure units should be pascals or newtons per meter squared, density units should be kilograms a meter cubed, and gravity should be in meters per second, and the height should be in meters. If the height increases like this case, the height delta or height 1 minus height 2 should be negative. So in this case it's negative 10 meters. If you're to have a height decrease, then the height delta would be positive. After plugging in all of our numbers into the formula, we get a pressure at point 2 of 901.9 kilopascals. We can see that the pressure dropped due to the height increase. That concludes this video. Hopefully I've earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Thanks for watching.